Alright, so today we're looking at lesson 10. We're going to be looking at motion graphs. So hopefully after this lesson you'll understand how motion graphs work. Our definition of average velocity is this formula that we've already looked at. We're going to be using that formula today. If the velocity is a constant between t1 and t2, then it's just going to be a straight line if you graph it, and the slope is going to just equal your average velocity. So if you look here, this is a straight line, and so your slope, whatever the slope is of this line, is going to be the average velocity. And so you would just go up 20 and over 2, so 20 divided by 2 would be 10, so the average velocity of this particle would be 10. Any 2 points on the straight line can be used to compute the slope of the line. So you can use this one and this one and that one, or the first and the last one. The value of the slope always equals the average velocity of the object. In this graph, though, the graph is curved between 0 and 3, so that the velocity must be continuously changing during that time interval. It doesn't stay the same. It's going faster, and then the velocity starts slowing down. The velocity is constant between 3 and 4, and that we know that because it's a straight line. It's also constant between 4 and 5, and between 5 and 6, because those are straight lines that connect those points. So if we want to look at the average velocity between 0 and 6, we're just going to connect those two and look at the slope of the line that connects those 2 points. The same procedure for reading velocity versus time can be used for acceleration. So we already talked about this formula a few lessons ago, and so we can use the same kind of formula for acceleration. So this one, we would be looking at acceleration because it's velocity and time. And so none of the graph has any straight segment, so that means that your acceleration is constantly changing. So your average acceleration is just connect the 2 points and what is the slope of that line. In this graph, that means that we have to have a constant acceleration here, and a constant acceleration here, because each of those 3 pieces are straight. So let's look at this example. This is a motion graph of position versus time for an object moving parallel to the x-axis. What is the average velocity for the first 2 seconds and for the first 6 seconds? And so a note on these motion graphs, when we're looking at graphs, we assume that we can read the graphs to 2 significant digits. So that's something we always do with those. So for A, the average velocity. So the first 2 seconds, we're going to do 2 minus 0 for time 2 minus time 0. Here, it looks like the position ends at 40, and we started at the origin. And so if you simplify that, you're going to get 20, and you have to put a bar because we have 2 sig figs, and we're looking at velocity. So meters per second, and that would be your answer. Now for B, it wants for the first 6 seconds. So our time, we ended at 6, we started at 0, and at 6 seconds, it looks like we are at 60 meters. So you're going to do 60, and we started at the origin. So 60 over 6, which is going to be 10. And again, we have 2 sig figs, so we're going to have to put a bar. And then your units are meters per second. And so that's how you do your motion graphs. That's the basic way to do them. They're not terribly difficult, but you do have to know what you're doing with them. Okay, so let's look at another example. This one is velocity versus time. What is the average acceleration between 3 and 6? So we start with 6 minus 3. And so at 6, it looks like our velocity is 40. And then at 3, it looks like our velocity is 160. So if you subtract, you're going to get negative 120 over 3, which is negative 40. And then how many sig figs should we have on these? We should have 2 sig figs because we assume we have 2 significant figures on these graphs. And then it's kilometers per hours squared. So that would be your answer for that one. Okay? So now we're going to look at the area between your velocity versus time curve and the t-axis between any two times t1 and t2. That's going to be the net distance that you traveled, your displacement during that period. So I think an example will help you with this one. We are told when t equals 0, it had an x position of negative 100. And they show us the graph. What was the position when t equals 6? And what was the average acceleration? What was the average acceleration? So let's start with A. That's the part we were just looking at. Basically, what we're going to do is split this into figures. This right here is a rectangle. And if you do the velocity times the time, you get 80. If you do this little triangle here, velocity is 20. And we only go over to 4.5, so that is a half times 20, and then it's a triangle, so you have to divide by 2. So that gives you 10 divided by 2 gives you 5. Okay, and then if you look at this one, this is a triangle, and this is 1.5. And we go down to 60. So 1.5 times a negative 60. And then divide by 2 should give you negative 45. So you basically just split it into shapes and connect them to your x-axis. And then we're going to add those together. But we started at negative 100. So we had negative 100, and then we went a positive 80, a positive 5, and a negative 45. So if you add those all up, you should get negative 60. And so that's the position at the end. And again, you have 2 sig figs, so it's in meters, so negative 60 meters would be your answer for A. So that's how you deal with your motion graphs whenever it asks about the position. Now it says, what is the average acceleration? So that was A. For B, you're going to do for the first 4 seconds. So 4 minus 0. Now at 4, we were at 20, and at 0, we were at 20. So we're going to do 20 minus 20, which is 0 over 4, which is just 0. So 0 meters per second squared. And you can't really do sig figs on 0 because you just can't. So don't worry about, if your answer is 0, don't worry about trying to do your sig figs. Okay? For part C, what was the average acceleration for the next 2 seconds? So that's going from 4 to 6. So we're going to do 6 minus 4. So at 6, we're down here at negative 60. And at 4, we were at 20. So you should have negative 80 over 2, which is negative 40. And it's meters per second squared. And we, again, have 2 sig figs. So we're going to put a bar over our 0. So that's how those work. Okay, so now we're going to look at another example. They want to know what is the position when t equals 25. So the book is showing you this is a negative displacement and this is a positive. If it's below the x-axis or the t-axis, it's negative, and if it's above it, it's positive. So I'm going to break this into a triangle. And so that's a 10 and a 100. and divide by 2. Which is going to be a negative 500. And then if we do this triangle here, 5 and 100 and divide by 2 is negative 250. And you could have done this whole thing times negative 100 and divide by 2. Like just treat it as one big triangle if you wanted to. Either one is fine with me. And then we have this triangle here. And so that's a 10, and we go up to 50 and divide by 2. So that should be a positive 250. So we started at 100 to the right, so that's 100, that's positive. And then we went minus 500, minus 250, and plus 250. So if you add those all up, you should get negative 400. And position is in meters for this one. We have only 2 sig figs for our graph, and this one has 3, so we're going to have to do 2 sig figs, so we're going to put a bar over the first 0, like that. For part B, what was the average acceleration between 15 and 25 seconds? So we're going to do 25 minus 15. At 25, our velocity was 50. And at 15, our velocity was 0. So 50 minus 0 is 50. 25 minus 15 is 10. And divide by, you get 5. And again, we have to do 2 significant digits. So 5.0. And then meters per second squared. So that would be your answer for that one. So that's how you do motion graphs. They're not terribly difficult. The hardest part is just making sure that you read the points correctly. So make sure to do your homework tonight, and it's 1 through 20, and then there are 5 curveball questions. And so the curveball questions started with lesson 10. They give you a question, and then they give you the answers. And the questions are just trying to help you think through some concepts that we're going to cover later on in the year. So, cite some benefits and drawbacks for using the length of a person's foot as a base unit for length. So it tells you what the answer is down there, but you think about it before you start using, before you start looking at the answer. Try and think about those a little bit before you read through the answers. So those aren't ones that you need to work through or anything. Those are just thought-provoking questions. So don't skip those, because they are going to help you later. They may show up on a test at some point. So just kind of think through those a little bit.